Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have this function y equals e to the power 3x minus x square, and we have to find the equation of tangent line. So to find the equation of tangent line to the graph of this function at the point 3, 1. Okay, so let me remind you what is the equation of a line, or how we can write the equation of this line. Now notice that we have a point that will be on the line already. So if we can figure out the slope of this line, we can write down its equation. So recall the point slope form of a line. And what is a point slope form? So if you are given a point, say x1, y1, and suppose the slope of the line is m, then the equation is y minus y1 is equal to m times x minus x1. Okay, so in our problem right here, we already know our x1 and y1, right? This is our x1 and this is y1, because that is a point on the line. So we can write down our equation. Y minus y1 is 1 is equal to m times x minus x1 is 3. So see, we are almost there to write down the equation, but we are missing the slope. So we have to figure out what is m when this line is going to be tangent line to the graph of this function. So how do we calculate slope? So our function is, let me write down one more time, it is e to the 3x minus x square. So what is the slope of tangent line? Recall that slope of tangent line to the graph of a function is nothing but the derivative of that function. So if we can calculate the derivative of this function, we will know the slope. So m is dy dx, which means it is the ddx of this function e to the 3x minus x square. Now how do we evaluate this derivative? Recall again that this function looks like e to the power some u. And in that case, the derivative is, write down e to the u and take the derivative of u as well. So that means our u is 3x minus x square. So this is e to the 3x minus x square. And then you have to take the derivative of that u. So this entire function in the exponent. Okay. So this part remains as it is. And then write down the derivative of 3x minus x square. So the first term 3x, the derivative is 3 times the derivative of x is 1. And then using power rule, the derivative of x squared is 2x. So simplifying it a little bit more, this is 3x minus x squared times 3 minus 2x. That's the derivative. So that gives the slope of the tangent line to the graph of this function at any point x, y. But notice, we need the slope of the tangent line for this particular tangent line that will pass through the point 3, 1. So we have to find a particular slope. So we need slope at 3, comma 1. And how do we calculate that? So that is, you take the derivative and apply this point. So we want our derivative at this point, but notice in the derivative formula that we have, we only have the variable x. So we need to compute the derivative at x equals 3. So let's do that. Here is our derivative expression and plug in x equals 3. So we get e to the power 3 times 3 minus 3 square. And then this whole thing is multiplied by 3 minus 2 times 3. What is that? Notice that here you have 9 minus 9. So you get e to the 0. And you have 3 minus 6. 3 minus 6. So this is minus 3. And using the exponent property, we know e to the 0 is 1. So this is negative 3. That is our slope. So this whole thing that we're computing is the slope that we need to complete this equation. All right, so let's come back to our equation and write down the slope. So m is negative 3 times x minus 3. And if you want, you can just rewrite this equation nicely. So the right hand side, let's distribute the negative 3. So we get negative 3x, and negative 3 and a negative 3 will make it a positive. And 3 times 3 is 9. And then write down as y equals, take the negative 1 to the right hand side. So negative 3x plus 9 plus 1. So you get y equals negative 3x plus 10. And this equation is the equation of the tangent line to the graph of this function at the point 3, 1. Thank you.